Hello everyone, myself Dr. N.CH.Ramgopal, working as Associate Professor in Mathematics in the Department of Humanities and Sciences, MLR Institute of Technology, Hyderabad. I welcome you all to today's session on exact and non-exact differential equations. This topic comes in the course Linear Algebra and Calculus. Today I am going to introduce the differential equations and types of differential equations, and then the methods of solving differential equations and exact and non-exact differential equations. Now, what is a differential equation? It is an equation involving derivatives. A simple definition. An equation involving derivatives. If there is a derivative in that equation, that it can be called differential equation. Now, what is a derivative? To know about a derivative, first there are two types of variables. One is dependent variable and the other is independent variable. The variables are two types, dependent and independent. In general, we take y. Let us suppose, let y be the dependent variable and x independent variable. Now, what is the meaning of dependent variable? Dependent variable means that depends on some other variable, whereas the independent variable doesn't depend on any other variable. The best example for that is time t. Time doesn't depend on any other variable. So, time is always an independent variable. So, here if x is a variable, then dx denotes the change in x, how the x changes. Similarly, dy denotes the change in y. Since y depends on x, y itself means it is a function of x. So that's why in general we write or we use this notation y equal to f of x. What does it mean? Y is a function of x. So y depends on x, but x doesn't depend on y. So here, since y depends on x, whenever there is a change in x, automatically there will be a change in y, because y depends on x. So the change in y will be with respect to the change in x. So this is called derivative, and derivative of y, and the main point is derivative will be for the dependent variable only. The numerator variable is the dependent variable and the denominator is independent variable. So the derivative is for dependent variable. So this is called derivative of y, first order derivative of y. Similarly, you can define the second order derivative, third order derivative, and so on. So this is called derivative. Here y depends on only one variable. For example, there is a variable z which is the dependent variable, and there are two independent variables x and y. That means z is a function of x and y. So the change in z is with respect to x as well as with respect to y. Z depends on two variables. So such a function is called function of two variables. So in the case of functions of several variables, that means two or three or more variables, we introduce the partial differentiation. So we find the partial derivatives. The change in z with respect to partially with respect to x and partially with respect to y, since z depends on both variables. So here we use the notation dou by dou x. D means the ordinary derivative and this is the partial derivative. And there is a lot of difference between these two, and it is very simple to evaluate a partial derivative when compared to an ordinary derivative. For example, y is a function of x. Then to find d by dx of x into y, here y is also having x. So we need to apply UV rule since we are differentiating with respect to x. So which is x dy by dx plus y into derivative of x is 1. So this is x y dash plus y. For example, if z is a function of two variables x and y, and we are calculating dou by, for example, this is xy, dou by dou x of xy. In partial differentiation, while differentiating partially with respect to x, we treat other independent variables as constants. So here, as we are differentiating partially with respect to x, we treat y as constants. So I can write y outside, dou by dou x of x, that means the derivative of x with respect to x is 1, so the answer is y. Here xy dash plus y, here y. So that much difference is there. First thing, you need to identify which is the dependent variable and which is the independent variable. And the second point, in the case of functions of several variables, we introduce the partial differentiation. So whether it is ordinary derivative or partial derivative, an equation involving derivatives is called a differential equation. So that's why the differential equations are two types: ordinary differential equations and partial differential equations. How to define an ordinary differential equation? An equation involving one or more dependent variables. Dependent variables can be more than one also, but independent variable is only one, exactly one independent variable. Whereas here, one dependent and more than one independent variables. So that is called a partial differential equation. So let us consider one dependent variable. So an equation involving one dependent variable, exactly one independent variable, and the derivatives of the dependent variable is called ordinary differential equation. And an equation involving one dependent variable, just I am considering one, more than one independent variables, and the partial derivatives of the dependent variables. And it is to be noted that the derivative is for dependent variable only. Coming to the ordinary differential equations, ODEs. The order of the differential equation is the highest order derivative that occurs in the equation, and also the degree is the power of highest order derivatives when the equation is free from radicals. So these definitions are the basic definitions that you know already. Now let us consider first order and first degree ordinary differential equation. First order and first degree. The standard form of first order and first degree differential equation is dy by dx equal to f of x comma y. So here the dependent variable is y, independent is x, that's why we have the ordinary derivative which is a function of x and y. So this is the standard form of ordinary differential equation. And the general solution. So again, the solution is of two types. One is the general solution and a particular solution. So whatever may be, what is the solution of this differential equation 1? Solution means which one is to be calculated. So here, what is the dependent variable? Y. So the differential equation is said to be in terms of y. It is a differential equation in y. So the solution means y itself. Find y. And the general solution, here to find the solution y from this differential equation, we need to eliminate this derivative. So here we have dy by dx. I don't need this d by dx. How to eliminate that? Since the integration is the reverse process of differentiation, simply by integrating on both sides, we can find the general solution of the differential equation. So for example, here, if you apply integration on both sides, d by dx of y is integral f of xy. Here these two gets cancelled, and let us suppose the integral is possible, and finally we got the answer as phi of x, and after integrating we introduce the integral constant c. So this is the final solution, y equal to phi of x plus c. So this is called the general solution of the differential equation 1. General solution consists of arbitrary constants c. Now for example, if along with this differential equation an initial condition is given, let us suppose y at 0 is 1 or y at x naught is y naught. By applying this condition on this solution, we can find the value of c also. So by giving particular value to c, we can get the particular solution of the differential equation. general solution consists of arbitrary constants, whereas particular solution is having the value for that arbitrary constant. So, the solution of the differential equation means to find the value of the dependent variable itself. What is the dependent variable here? Y. So, find y. Now, how to find that solution? So, the standard form is dy by dx is f of x comma y. If the integration is possible directly, then simply we can evaluate the solution by integrating on both sides. But always it may not be possible, since that depends on the function or the terms involved in the differential equation. So, that is why there are many methods to solve that first order ordinary differential equation. One of those methods is variable separable method, which is a simple method. Just separate the variables if possible and then integrate. So, if it is possible to separate the variables, write x terms on LHS, y terms on RHS and then integrate, or y terms on LHS, x terms on RHS and then integrate. That is variable separable method. Similarly, there is another method, homogeneous differential equation. So, there is a particular format for that homogeneous differential equation. So, if the given differential equation is homogeneous, there is a method to solve that differential equation. Third one is non-homogeneous differential equation. And fourth, linear. Fifth, Bernoulli. So, like that there are many methods, and one of those methods is exact differential equation, or exact or non-exact differential equation. So, these are the basic methods that you know already. Now, today I am going to introduce what is an exact and a non-exact differential equation. So, first the standard form is dy by dx equal to some function of xy dx. This function may have different terms, sometimes x and y separate or both together also. So, by simplifying this, I can write it as dy into f of x comma y, dy into f of x comma y dx. So, some function into dy is equal to some function into dx. So, there is a particular format for the equation. First, if the given differential equation is in the form m dy plus n dx, if the given differential equation is of the form m dx plus n dy is equal to 0, where m and n are functions of x and y. So, simply I can write it as m dx plus n dy equal to 0. First, the equation should be in this form. You need to write the given first order differential equation in this form. Then identify the functions, what is m, what is n. Then find dou m by dou y. M, and here one more point is the function before dx is m and before dy is n. The function before the differential dx is m and before the differential dy is n. So, identify the functions and then find dou m by dou y and dou n by dou x. There is no confusion. Differentiate this function with respect to the other variable. Here dx, before dx we have m. So, differentiate m with respect to y and differentiate n with respect to x. So, dou m by dou y and dou n by dou x. If dou m by dou y is equal to dou n by dou x, then the differential equation is said to be exact differential equation. So, if these two partial derivatives, just now we have discussed about how to find the partial derivatives. So, dou n by dou y equal to dou n by dou x, then the equation is said to be exact. Otherwise, that means if dou n by dou y is not equal to dou n by dou x, it is non-exact differential equation. So, first the equation should be in this form and then dou m by dou y equal to dou n by dou x. Then the equation is exact differential equation. If it is exact, then we can write the solution, the general solution. We can write the general solution directly. U plus integral phi of y dy equal to some constant c. So, where u is integrate the first function m with respect over x. Over x means by treating y as constant. By treating y as constant, integral m dx. And phi of y, what does it mean? Phi is a function of y, so exclusively a function of y. So terms independent of x in, already we have used m, now use n. Terms independent of x in n, or the terms without x, free from x. There must be only y terms. So find u and then phi of y and substitute here. This is the solution of an exact differential equation. As an example, consider the differential equation y dx plus x dy equal to 0, which is in the form of m dx plus n dy equal to 0, where m is y and n is x, and dou m by dou y is 1, dou n by dou x is 1. So dou m by dou y equal to dou n by dou x. So the equation 1 is exact. And if 1 is exact, how to find the solution? Directly you can write the solution. U plus integral phi of y dy equal to c. It is very easy to remember this. So where u equal to integral m dx over x. What is integral m? M is y. So integral y dx over x. So we can treat y as constant. Integral dx. Integral dx is these two reverse processes, so gets cancelled. So the answer is xy. And what is phi of y? Terms independent of x in n. But n is x. There is no term without x. So phi of y is 0. Therefore, the solution is u plus integral phi of y dy equal to c. U is xy plus integral 0. So xy equal to c is the solution of the differential equation. So if you identify that the equation is exact, it is very easy to find the general solution. Simply u plus integral phi of y dy equal to c, where u is the integral of m with respect to x by treating y as constant, and phi of y is terms independent of x. Now coming to, for example, let us consider another example. M y dx minus x dy equal to 0. So which is in the form of m dx plus n dy equal to 0, where m is y and n is minus x. So to check whether it is exact or not, we need to find the derivatives, partial derivatives, dou m by dou y and dou n by dou x. Here it is 1 and minus 1. So it is very clear that dou m by dou y is not equal to dou n by dou x. That implies the given differential equation 1 is a non-exact differential equation. Now, if it is exact, we can write the general solution directly. But if it is not an exact differential equation, then how to find the solution? Now, let us consider the given differential equation. So this is equation 1. Now, multiply equation 1 with 1 by x square. Let us multiply this with 1 by x square. Then let us check what will happen. Y by x square dx minus 1 by x dy is 0. So which is also in the form of m dx plus n dy equal to 0. But already we have used that notation here, m and n. So let us use a new notation, m1 dx and n1 dy, where m1 is y by x square and n1 is minus 1 by x. Then what is dou m1 by dou y? With respect to y, we treat x as constant, 1 by x square into the derivative of y is 1, and dou n1 by dou x minus 1 by x derivative is minus 1 by x square, which is plus 1 by x square. Now it is very clear that dou m1 by dou y is dou n1 by dou x. So that means the new differential equation the differential equation 2 is exact. Here 1 is not an exact differential equation, but 2 is an exact differential equation. How we have obtained this exact differential equation, or how this equation 1 is transformed to 2? By multiplying with a factor 1 by x square. So that factor is called integrating factor. Integrating factor. Now you might have understood how to solve a non-exact differential equation. Just multiply the non-exact differential equation with this integrating factor that reduces to exact form. So a non-exact differential equation can be reduced to an exact differential equation form by multiplying with a factor which is called integrating factor. Yeah, of course, here I told you to multiply with this 1 by x square. Similarly, you know, you can multiply the equation with 1 by y square also. Again, you will get the exact differential equation. And not only that, 1 by x square plus y square also. So all these are integrating factors. But how would you know that the integrating factor is 1 by x square? Today I have explained by taking this factor 1 by x square. Otherwise, how would you know to find that, to identify that integrating factor? So that's why they have introduced some methods to reduce the given non-exact equation to exact form. So by finding the integrating factor and multiplying with the non-exact differential equation, we can reduce it to exact form, and then we can solve it to get the general solution. And there are 4 or 5 methods to methods in non-exact differential equation to reduce it to exact form. So that we will discuss in the next session. So this is for today's session. Thank you very much.